So look at this problem where a number of capacitors, 1 microfarad capacitance, each capacitance or each capacitor is standing a potential difference of 100 volts available. That is each capacitor of capacitance 1 microfarad and it can withstand 100 volts. That means the maximum charge it can hold is Q is equal to CV 100 microcoulombs. Now we want to have an equivalent capacitor of capacitance 0.5 microfarad and total voltage it can withstand is 1000 volts. So I have many capacitors of different of each capacitance 1 microfarad, it can withstand 100 volts. Okay. From that I want to construct a capacitor having 0.5 effective capacitor, 0.5 microfarad and withstanding 1000 volts. Okay, this is what we want. Okay, just look at this. Now, if I connect 1 microfarad, 1 microfarad, 1 microfarad like this, 10 capacitors if we connect and voltage is 82. So total voltage is 1000 volts and each capacitance is 0.1 because 1 by C is equal to 1 by C1 plus 1 by C2. The capacitance of this series is 0.1 and it can withstand 1000 volts. Just imagine like this, we have 5 sets. Okay, 5 sets. Okay, so the total capacitance is 0.5 because parallel 0.5 microfarad, and since voltage is parallel 1000 volts. So finally, so we need 10 condensers or capacitors in series, 5 rows in parallel. That is the answer. Okay, so you have to, this set we need 5 sets. So each row 10 capacitors multiplied by 5. So answer is 10 capacitors in series, 5 rows in parallel. So look at the next one. A number of small liquid drops, each capacitance C, potential V, combine to form a large drop. If the potential of the large drop is 100 volts, what is the capacity of the bigger one? So we know that capacity of a capacitor is 4 pi epsilon naught R, potential is Q by 4 pi epsilon naught R. Okay. Like that we have N, 1, 2, 3, 4 dash dash N. Look at this one. Okay. So when N drops coalesce or combine into a single drop, the total charge on the bigger drop is NQ, and since volume is conserved, N by 4 by 3 pi R cube into is equal to 4 by 3 pi capital R cube, so that we'll get relation between capital R and small r. Capital R is n to the power of 1 by 3 small r. Fine. Then we know that the voltage of bigger drop is NQ by 4 pi epsilon naught capital R. So we can express this in terms of voltage of smaller drop. Here what is this V? Voltage of smaller drop. Okay. So substitute. Yet it is given that voltage of bigger drop is 100 volts. So 100 volts is equal to 10 to the power of 2, n to the power of 2 by 3 into V gets cancelled. From that we will get n to the power of 1 by 3 is 10. Okay. And we know that capacity of bigger drop is 4 pi epsilon naught R. Substitute capital R in terms of small r. Okay. You will get capacitance of bigger drop is 10 times the capacitance of smaller drop. So the answer is 1.